Have you ever seriously thought about turning back the clock on aging? I mean, really reversing it, not just slowing it down. For the longest time, that was pure science fiction. But what we're going to talk about today is how that fiction is quickly, and I mean quickly, becoming scientific fact. Let's get right into it. So, here's our game plan. We'll kick things off with that big sci-fi dream of rejuvenation. Then we'll get down to the nitty-gritty of what aging actually is by looking at its biological hallmarks. After that, we'll dive into two incredible frontiers, rewriting our cellular code and, get this, using light as a form of medicine. And finally, we'll pull it all together to see what the future of youth might actually look like.
All right, so let's start with the ultimate fantasy. Just imagine a future where aging isn't this thing that just happens to us, this inevitability. Instead, what if it were just a condition, something that could be treated?
I mean, check this out. This concept is straight out of a sci-fi playbook. It's a rejuvenation bed, a completely non-invasive device that could diagnose and repair every single cell in your body. It sounds absolutely incredible, almost like magic, right? But this is the question that's driving scientists all over the world. Is this just a cool picture, just pure fantasy? Or are we actually seeing the real-world beginnings of this kind of technology today? Well, if you really think about it, that sci-fi bed isn't as far-fetched as it seems. The concept needs a machine that can non-invasively get through the whole body, right down to the bone. And honestly, that looks a lot like a modern MRI machine, doesn't it? So the dream is ambitious, for sure. But to even begin to build that future, we have to understand the enemy, aging itself. To turn that dream into reality, we've got to understand the fundamental problem. So what is aging on a biological level? Well, scientists have now identified the core issues that we need to solve. And the scale of this challenge, it's just staggering. The human body is made up of roughly 37 times trillion cells. Any true rejuvenation technology would have to work on all of them. So where in the world do you even begin? You begin here. This is the roadmap. Back in 2013, scientists officially categorized the aging process into these 9 distinct hallmarks. And this was a monumental step. It's like going from fighting a monster in the dark to having a detailed blueprint of your enemy. By understanding these specific types of damage, from our DNA becoming unstable to our cellular power plants breaking down, researchers finally have a checklist, a unified plan for how to tackle the problem. Let's zoom in on just one of these to see what we're talking about. Cellular senescence. These have a much cooler nickname, zombie cells. And it's perfect, because they're old, damaged cells that are supposed to die, but they don't. They just hang around leaking out this inflammatory gunk that damages all the healthy cells nearby. So yeah, clearing out these zombies is a major, major goal. So, okay, we know the enemy. How do we fight back? Well, the first big approach is maybe the most audacious one of all, genetically reprogramming our own cells. And just look at this timeline. We've been on this path for a while. This isn't some overnight discovery. It goes all the way back to the 1930s, when we found out that simply restricting a mouse's diet could extend its life. Each one of these discoveries built on the last, leading us to a point where today we can actually reprogram cells. Now, the absolute game changer was this Nobel Prize-winning discovery. Scientists figured out that a specific cocktail of genes called the Yamanaka factors could take an adult cell, like one from your skin, and hit the rewind button, taking it all the way back to an embryonic-like state. This was the first proof that a cell's age wasn't a one-way street. It could be reversed. But this incredible power comes with a huge risk. If you rewind that cellular clock too much, the cell can lose its identity and just start dividing uncontrollably. And that is the very definition of cancer. So the whole trick, the crucial challenge for researchers, is finding a way to get that rejuvenation without triggering that dangerous side effect. And the progress is real. Researchers at Stanford found a way to temporarily lengthen telomeres. Those are the little protective caps on our chromosomes. And what happened? The cells behaved younger, they multiplied more, but, and this is the key, they didn't become immortal or cancerous. It was a massive step towards safe, effective therapies. Okay, so that's genetics. Now let's switch gears completely from biology over to physics, because another fascinating area of research is exploring how we can use specific wavelengths of light to directly influence our cells and fight aging.
The scientific name is photobiomodulation, or PBM for short. You've probably heard it called low-level light therapy or maybe cold laser therapy. The core idea is that you can apply specific kinds of light to the body and trigger all these beneficial biological responses, all without any drugs or surgery.
So how does that even work? Well, to put it simply, specific wavelengths of light are like a key that fits a lock inside our cells. That lock is located in our mitochondria, the powerhouses of the cell. When the light energy is absorbed, it kicks off a chain reaction that ramps up the production of ATP, our body's energy currency. And that in turn reduces stress and kickstarts a whole bunch of healing and repair processes. Now, not all light therapy is created equal. You can deliver it in a constant, continuous beam, or you can do it in rapid pulses. The real advantage of pulsing the light is that it cuts down on heat. This allows you to use a much higher peak power, which then lets that beneficial light penetrate way deeper into your tissues, reaching areas a continuous beam just can't. And just to be clear, this is not theoretical stuff. Photobiomodulation is already being used in clinics today for a huge range of things, managing chronic pain, speeding up how fast wounds heal, reducing inflammation, you name it. It's a versatile and powerful tool that's already a part of modern medicine. So we've got these two amazing fields, genetic reprogramming and light therapy. How do they come together? How do we synthesize all this to build that future without aging? Well, here's the crucial connection. All roads lead to the mitochondria. Remember mitochondrial dysfunction, one of those core hallmarks of aging? It turns out that nearly every major rejuvenation strategy, whether it's genetics, diet, or light therapy, directly or indirectly targets the health of our mitochondria. They are the central hub in this fight against aging. This really shows the combined approach scientists are taking now. They're attacking the problem from all sides. From the outside in, by messing with things like our environment and our circadian rhythms, and from the inside out, by targeting our genes, our metabolism, and clearing out those zombie cells. It is a truly holistic strategy. So the main takeaway here is that while that sci-fi rejuvenation bed might still be a ways off, it's not just a fantasy anymore. All the individual pieces, the genetic software, the light-based energy systems, the deep understanding of how our cells work, are being built piece by piece in labs all over the world right now.
And that leaves us with one final profound thought. As we get closer to solving the biological problem of aging, we're forced to confront an even bigger question. If a finite lifespan is no longer a given, if we can halt or even reverse aging, how does that change our society, our purpose, and the very definition of what it means to be human?